our product engineers also write automated UI tests for their story's acceptance criteria. So then the team themselves actually performs manual QA before the story is considered to be done. So we have automated tests that run after every push to master or release branches. And we also do manual regression testing in addition to the automated testing before we push to production. So you may ask yourself, well, if the developers are doing the majority of the testing themselves, what do testers at SoundCloud actually do? So we have a role that's called Software Engineering in Test, and basically our role is to provide tools and services that will enable the product developers to build and release high-quality software efficiently. And really, to be able to do this, we have to understand the team's pain points and come up with solutions that help them improve their efficiency. So I'll look at what we have for continuous integration. So we use Jenkins, and we have pipelines on Jenkins. So as you can see here, this is what the pipeline looks like for the Android master branch. So we have separate stages for building, testing, and deploying. So as part of the build stages, we do compilation for both the application APK and the test APK, as well as performing some static analysis. If that's all good, then we'll move on to the testing phase. So we run the unit tests as well as the automated UI acceptance tests. And we also have a stage that is called Dex Watchdog. So it keeps track of the methods that we have so that if we're reaching the Dex method limit count, we get notified before a release, which is really nice because that's been a problem in the past. And again, if that's all good, we can deploy to alpha manually, or this is a job that is also scheduled to run once a night. So this will push through Crashlytics beta to our alpha users, which are just internal users. So how do we write our UI tests? On Android, we use a customized version of Rebodium. So basically, we use Rebodium for clicking and dragging, and everything else has been highly modified to suit our specific needs. And for iOS, we use Frank with Cucumber. So for writing our UI tests, we borrow a concept from web automated testing world, which are called page object models. So basically, page object models model a page or a screen in an application that tests then interact with, and this accomplishes a few things. First off, we reduce duplicated code in tests, and we also limit code refactoring after UI changes because all of the page object models are stored in one place as opposed to implementing them in each test instance. And this ensures that tests only care about the services that they interact with and not the implementation details. So we want the tests to be as dumb as possible and page object models to be figuring out all the hard stuff for us. So page object models are really the only thing that have a deep knowledge of the page or parts of a page, which is also pretty cool because if you have repeating elements in a screen, you can use the same page object model as opposed to rebuilding it again. So they also have a few responsibilities, which would be to identify elements on the screen and return any of those elements attributes that you might be interested in. So it knows how to select the right elements on the page, and every public element or public method should return another page object. So for instance, if you're interacting with an element on screen that after the interaction stays on the same page, then you would return another instance of the same page object model that you were previously on. Whereas if you click a button and it takes you to a new screen, you would return a page object model for the new screen. I skipped a slide, sorry. My slide is not there. Whoops, okay. Well, I had an animation of showing what's going on in the app explaining this, but I'll just explain it myself. So when you open the SoundCloud app as on Android as a non-logged in user, you get a home screen, which has a toolbar at the bottom, which contains 2 buttons, and one of the buttons is to create an account. And when you click on that button to create an account, it brings you to a new screen that allows you to select a few methods for logging in. So you can use your Google Plus account or your Facebook account, or you can sign up with your email address. So this is an example of a page object model for clicking those buttons in that interaction. So at the bottom, you can see that we have a private method that finds the bottom bar based off of its ID. And then we can, from that view element, search for the sign up button based on its ID. And then we have a method called click sign up button that finds the button that you're looking for, clicks it, and then returns a new instance of the sign up screen page object model. So, yeah. So that's a brief overview of how we build the acceptance tests. Now you might be wondering, how do we actually run these? So there's 2 kinds of approaches when you're running UI tests on devices, which would be parallelization or fragmentation. As you all know, there are a lot of different devices out there, or even just different OSs. And you might think, well, you know, we want to test on all of the matrix of different devices that we possibly can to make sure that everything works. Or you can do parallelization, which means you have an array of very similar devices and you break up your tests and run them in parallel across many devices. So we go for the parallelization approach. And to do this, we have 34 Nexus 5 devices, which are all running Lollipop, as well as 2 emulators, and I'll explain later why we use 2 emulators. For iOS, we have 22 Mac Minis. In each of those is running a VM, so we have 44 iOS simulators that are running iOS 8.3. So why Parallelize? Well, we found that the benefits that we got from running our tests in series on a bunch of different devices didn't outweigh the benefits that we would get from running tests faster if we split them up over many similar devices. So to put a number to this would be 1 hour, 42 minutes, and 19 seconds, which is how long it would take to run all of our iOS UI acceptance tests on one device. Or even worse, 2 hours, 1 minute, and 23 seconds, which is how long it would take on Android on one device, which basically just leads to this developer cat getting very sleepy at the keyboard, waiting for test results to come in because they're just taking way too long. So as a solution, we built some customized test runners, and these were Ruby gems. So for Android, we use Verbodium, which is actually an open source project that you can check out at this GitHub link. And for iOS, we built Distributed Cucumber and Commander, which are internal tools. So with these, basically, you might be wondering, well, what do they actually do? So they take an application and test packages and create a list of tests based on those 2. And then they determine all of the available devices that are connected. And then they run each test on a available device as long as there's another test left. Repeat, repeat until there's no test left. So this gives us a nice new number of 10 minutes and 4 seconds, which is how long it takes to run all of our iOS UI acceptance tests across multiple devices, or even nicer, 8 minutes and 11 seconds for Android. So in addition to the time savings, we also have a few other benefits. So you can specify some run configurations. So say you only want to run on a specific type of device, whether that be an OS version or a handset type. You can also specify a list of annotations that you only want to run. So it's just an easier way to run a specific collection of tests. You can also specify a set of annotations that you don't want to run. So if you have a set of broken tests or a feature is no longer enabled, you can just quickly disable those tests by specifying them by annotation. We also have much better debugging. So we have HTML reports, which are really nice because, well, within Jenkins, you don't really have a good overview of the whole test run while getting specific information about one test. And with this, you can sort of see everything all at once. And for every failed test, we provide the stack trace as well as the full logs. And initially, we provided screenshots of the failure point, which we thought was pretty cool at the time. But eventually, we upgraded this to videos because screenshots really don't capture everything that's going wrong in the test at the time. So yeah, it's pretty cool. So despite all these benefits, there are also some problems. So as I said before, the old test runners assume that you want to run on all available devices, which basically means that if you have 2 jobs running at the same time, they're going to be fighting for devices and maybe uninstalling a package while a test is trying to run on the same device. So we really have to rely on Jenkins for doing the job scheduling, which basically means that we can only run Jenkins jobs on this test environment, and it would be pretty cool if developers could also use this environment if they want to test. In addition to that, we have a few different configurations that run on master for both iOS and Android. So we have a job that runs for master branch as well as release branch. And these can't run at the same time. So basically, we have to block the jobs when they run, which leads to a lot of unnecessary waiting time. In addition to that, all of the run configurations are set within Jenkins jobs. So anytime you want to start a new configuration, you have to create a new Jenkins job, which, I mean, developers already have enough things to worry about, so they're not going to go play around on Jenkins and make a new job just for a one-off test that they want to run, which basically means that pre-commit testing isn't really feasible. In addition to that, the test running order can't be specified, so whatever order the test collector collects the test is the order that they get executed in. And test results are only collected from the devices after all of the tests are completed. So if it takes 10 minutes to run all of the tests and you only care about a few test results, you have to wait until the entire run has completed, which is not very efficient. Also, we retry failed tests once because there's certain flakiness just in network that we can't really control. But this wasn't really obvious from the test reports, and so issues that may be sort of flaky would just get swept under the rug because they probably passed the second time and nobody realized. So as a solution, we decided to create a new test runner for both iOS and Android that was bigger and better, and we call this mobile test runner service. So it's only for Android right now, but we have iOS support coming soon. It's mostly written in Scala, and it communicates with devices through ADB using ddmlib, which is a Java library. And we also provide a REST API for clients so that they can communicate really easily with it. So this is a really simplified overview of how it works. So basically, a developer gets their test package, their application package, any tools packages that they need, as well as specifying a configuration. And this gets passed to a test collector, which figures out which tests to run based off of the packages and the configuration, and then places the tests into a test queue. And meanwhile, all of the devices that we have are assigned in a one-to-one relationship with a worker, and the worker will poll the test queue for a test whenever it's available to run one. And then it manages the device. So basically, it will uninstall and reinstall the packages if it's a new test run, or if it's a test from an existing run, it will clear the package data from the application just so that the test starts in a clean environment. And then it will execute the test, and once the test is done, it will notify that the test is done, and also put all of the results into a database. And then once an entire run has finished, the worker will restart the device, just again to ensure that we have a clean state when we start the next test run. So this has come in handy a lot because we have some issues with Google services that will crash, and there's a pop-up, and the only way to get it to go away is to go up to the lab and press a button, which isn't very convenient, but we can just restart the device at the end of the run, and that clears the problem usually. So some of the results that we've gotten from the new test runner service. Resource management is controlled by the service itself, so we don't have to rely on Jenkins anymore, which means that test runs can be executed in parallel. And resources are used efficiently because the device workers are constantly asking for a new test to run as long as there are tests in the queue. And most importantly, developers can test their pre-commit changes on the same environment used by the CI, which is really cool. I mean, if you're just running on an emulator to make sure that some of your changes work and not really able to run the whole test suite on the same devices that CI uses, it can lead to some problems down the road. So the test queue ordering is also controlled by the service, so we can run the most important tests first. So for instance, new tests might be more important than old tests, so we can run those first. Or if we have figured out that certain tests are super flaky, we can run those last. Also, if a test failed the previous one we might want to know if it's still failing now, so we care about it more and would want to run it first. So test results, including the stack trace, full log, and videos for failed tests, are available as soon as each individual test finishes. So when you go to the HTML report, you can just sit there and have it reload automatically every time test results come in, which is pretty cool. And the retries for failed tests are clearly indicated in the HTML report. So if something failed the first time and passed the second time, that's really obvious, and you can go in and look and see if it was an actual product issue the first time it failed, or just a network issue or something else. And all the data from the device's tests and results are stored in the database, so we can do really quick queries to pull important information. So this is basically what the HTML report page looks like. It's not the nicest UI, I admit, but it works. So at the top, you can see that on this run, we had 78 tests, 1 failed, 1 passed. Up in the right-hand corner is the total execution time. So this is the time that all of the tests took to run if they were run in series. And then we have the test class and test name, as well as both attempts. So you can see that this test failed twice. There you have the stack trace, so you can see exactly what happened. If you're more curious about what happened during the entire test, you can click on the logcat log, which will show you the full log report, or you can click on the video link and watch what happened for yourself. So test runs are easily configured via the REST API. This is just an example of how that's done. So you specify your packages, what the package name and location is, and then you can pass in a label, which would be Lollipop or whatever OS version, which test runner you want to use. And then here we're specifying a list of tests, which is just one test based off of the class name and the test name. So that's pretty cool, but API endpoints can be annoying to remember and to configure. So we built a Java library that helps you do this. And we integrated it into the Gradle tasks so that all the test configuration that's done on CI is part of the Android code base. So instead of doing all of the stuff that I showed in the previous slide, you can just do Gradle run lollipop tests. But Gradle tasks have their problems too. They're not easily parameterized, and the names can also be annoying to remember. Also, going from Android Studio, where you can just right-click and run a test right there, to having to use a command line isn't super user-friendly. So we built an IntelliJ plugin. So now developers can run tests for local changes on CI right from Android Studio. You can right-click on a specific test method or a test class or a package and run all of the tests there. And test reports are there natively, including links to videos and logs for failed tests. So here's what the run configuration looks like in IntelliJ. You can specify, again, which label you want to run on, which test runner. You can specify which tests to include with annotations or exclude, or specify tests only in a package or class. Yeah, much nicer than having to finagle with API endpoints. And here's an example of what it looks like when you run a test with the IntelliJ plugin. So as you can see, everything's reported natively. You can see that 3 tests failed in this case. You have the stack trace with links to points in the code that might be beneficial for debugging, as well as the link to the log catalog and the video. So yeah, that's it.
Вопросы? О, я вижу. О, до вас ближе идти. Я до вас, вижу, помню. Да.
Hello. Thank you for your presentation. I'd like to ask how you deal with mocking a web server. I mean, backend API. Do you mock it, or you use real or some stage environment?
Yep. So when the easiest answer to your question is that we use the actual production service, which isn't always so great. So for iOS, we made a mock server, which worked pretty well until things started to get really complicated because our actual servers are very complicated. So my colleague actually wrote an open source project called RESTspy that lets you mock some endpoints and use the real server for others, which it's actually pretty cool. You can specify that, the first 2 times that I hit this specific address, I want a 500 returned, but the 3rd time I want it to go to the actual service and return what I'm actually expecting for. So you can ensure that your tests for failure cases work the first time and function with the actual expected result the 2nd time. Yeah.
Thanks.
Еще вопросы? О, есть. Первый ряд, активный ряд.
You said that the developers do initial Q&A, but isn't it expensive?
No. Plus, we find that we have smaller teams that are working on really small features, and it's more expensive to kind of come in and teach somebody about what the feature is than have your colleague who's been sitting next to you, not working on the same code, but is really familiar with the feature, just play around with it and make sure that it's working correctly and that it didn't break anything else.
Okay.
No.
I know this guy.
Another question. Why Robotium? Why not Espresso? It's more hipster-like,
Well, so we initially had a full suite of tests before Espresso really came out and was fully functional. And also, we decided that we don't want to rewrite all of the tests every time some new cool tool comes out, because it might not really be beneficial. It could just be a waste of time in the end. So we kind of just wait and see what the community has to say about a new tool before we invest the time in completely rewriting everything.
But as far as I understand, you can run also on Espresso with your custom runner, yes?
Yep. Yeah, it would be really easy. Yep.
Well,
Hey, thanks for the talk. So the question would be pretty similar with the Android question. Like I've seen you're using Cucumber for iOS testing particularly. So Cucumber. Okay. So the question is, what does your team think about the XUI test? Are you planning to implement it because it's pretty recent? So I guess you have all this huge test suite on Cucumber. So what do you think about XUI tests?
We're definitely looking into it. We have done a few experiments with it, but again, we don't want to invest the time before maybe other people have invested the time and reported back their findings. So we're going to wait a little bit, but it's definitely something that we're considering. Yeah.
Okay, thanks.
Yep.
Hurrah. Hurrah. Thank you a lot. Brigit from Soundcloud was here.